Jupiter is the king of planets in our solar system. Its mass equals 2.5 times the combined mass of all other planets in the solar system, and its volume could fit 1,300 Earths. Just its great red spot alone could contain 3 Earths. However, Jupiter's true mystery lies beneath its stormy atmosphere. From current cross-sectional views of Jupiter, Jupiter's atmosphere is like an apple's skin, just a small part of this giant planet. Currently, astronomers mainly use indirect methods to explore Jupiter's interior secrets. This includes observations of its atmospheric temperature and pressure. Jupiter's core temperature is estimated to reach about 44,460 degrees Fahrenheit. Core pressure ranges between 50100 million atmospheres. Under these extreme conditions, hydrogen may exist in a metallic state. It's worth noting that Jupiter's internal heat is twice the energy it absorbs from the Sun. This means, besides solar radiation, Jupiter's core itself is generating heat. Therefore, some believe Jupiter might become a star in the future. However, there are currently 2 main theories about Jupiter's core. One is that Jupiter has a solid core. This core formed in the early solar system and attracted large amounts of hydrogen and helium. Another theory suggests Jupiter might be composed entirely of gas, without a solid core. But the latter isn't accepted by most astronomers, because under Jupiter's high temperature and pressure, gaseous matter has no reason to exist. However, to completely solve this mystery, astronomers launched the Juno Jupiter probe. Its main mission is to measure Jupiter's gravity and magnetic field, to reconstruct Jupiter's core region conditions. So if we truly discover in the future that hydrogen inside Jupiter exists in an environment similar to the Sun's interior, then as the solar system's largest gas giant by mass and volume, Jupiter might undergo nuclear fusion in the future and become a second sun. Or could we ignite Jupiter like in the movies? The answer is no, it's impossible, because although Jupiter's mass is large and its composition is almost identical to the Sun, its mass, compared to the lower limit of stellar mass, is still too small. The smallest red dwarf stars in the universe have about 80 Jupiter masses. This means, unless Jupiter suddenly gains 80 times its mass, its core temperature and pressure are insufficient to ignite nuclear fusion and become a star. As for igniting Jupiter, that's even more impossible. While Jupiter's main component is hydrogen gas, combustion reactions require oxygen to occur. Neither space nor Jupiter itself contains oxygen. In fact, Jupiter's best possible future is to become a brown dwarf, also called a failed star. This type of celestial body exists between planets and stars, although it cannot emit light and heat on a large scale like stars. It has already left the planetary category, becoming a dark red celestial body. Overall, Jupiter as the king of solar system planets, although we cannot directly land on it in the future, if we master controlled nuclear fusion technology, Jupiter's inexhaustible hydrogen would become humanity's largest fuel station in the solar system. This way, spacecraft departing from Earth could refuel at Jupiter and reach more distant planets in the solar system. Additionally, Jupiter has the most moons in the solar system. Europa and Ganymede might even harbor life. So in the foreseeable future, Jupiter exploration will continue to increase.